Okay, what you see in front of you on the left hand side are the names of all the files that I've got on one of my USB sticks, one of my pen drives, okay? And obviously there are going to be thousands and thousands, as you can imagine. Look, if I scroll all the way down to the bottom, right, I've got 32,756. Right, a lot of files on that USB stick. And on the right hand side, it's got the file size, right, the size of each of those files. So this one here, it's got a file size of 9,614 kilobytes. Okay, so these are in kilobytes. What I'm going to do is I'm going to copy all these numbers, all these file sizes, and I'm going to paste it into this app. Right, so there you go. There's going to be obviously thousands and thousands here. Now, what I'm going to do in a moment is I'm going to press the submit button. So before I do that, let me explain what that will do. That will look at all these numbers, right? All the numbers, and find out how many of these numbers begin with 1, how many of these numbers begin with 2, 3, 4, 5, and so on, right? Let me press the submit button. Right, so this is talking in terms of percentages, right? You can see this first bar is the highest bar, right? That represents 1, 2, 3, 4, and so on, all the way to 9. And that's the biggest bar that I'm pointing at here. 28 as you can see there, 28.7% of all these numbers, right? All these numbers begin with 1. Right, then the next one, look, second highest bar, right? 15.5% of all those numbers that I've got begin with 2. And obviously you can see these numbers drop. Now that's interesting that so many of these numbers begin with 1. Right, what I'm going to do now is look at total COVID-19 cases by country. This is up to date as far as August 2020. You can see here, these are all the COVID cases by country. It doesn't specify what countries these belong to. But I'm guessing there are just as many numbers as there are number of countries on Earth. Okay, the biggest number there begins with 5. Right, you can see here the numbers further down begin with 1. Okay, all of these begin with 1. Now if you look on the bar chart over here, 27%, that's the highest proportion. 27% of all the data that we have here begin with 1. Second highest is 2, and then 3, and so on. You can see here, these bars follow the Benford's law distribution curve, right? Almost, okay? There's a slight discrepancy here, but still 1, 2, 3, 4, it follows that pattern. Right, let's try distance to brightest stars. I'm guessing these numbers are in terms of light years, right? And you can see once again, most of those numbers, the highest proportion, begin with 1, 2, 3, right? More or less follows the Benford's law distribution. Right, population of countries. Right, without a doubt, I can say that's China, that's India, right? And that itself, right, all this data follows the Benford's law distribution, right? Is it a coincidence? Because we looked at so far 4 types of data. We looked at file sizes from my USB stick, right? Some random USB stick, a pen drive that I got. We've looked at COVID cases, distance to brightest stars, population of countries. These are all natural things, right? Not made up, right? So all these numbers here, file sizes, right? I did not make this up. This came naturally from my pen drive, right? And all these files were created, stored over several years. And all of these follow the Benford's law distribution. But then if I try some random data, right? Just some made up data, does not follow Benford's law distribution, right? All these numbers don't follow Benford's law distribution. I can try a different set of random data. There you go. Does not follow it. Now, the question is this a coincidence? Now, what you see in front of you is tracking data from a company, how much money a company's made from selling different things, different items to different countries, different regions, right? So here on the first line, you can see £51,500, £76. What did they sell? Sold something to Azerbaijan. What did they sell? Snacks, okay? And it's given the date, right? There's a lot of information here. If I scroll down, all the way down, right, we're looking at, whoa, well over, we've got 100,000 pieces of data here. A lot of data. What I'm going to do now, I want to check to see if there's any kind of fraud happening here, right? All of this data is meant to be natural, right? If it is natural, it will follow Benford's distribution curve. So what I'm going to do now is I'm going to copy the last column, the profit column, and I'm going to paste that into this app. Just takes a while. Right, so I've got it here. It's 100,000 pieces of data here. Right, press submit button. Right, it'll take a while to analyze this because there's a lot of data here. There you go. So this highest proportion of these numbers, of all these numbers, begin with 1. Second highest 2. Seems like, yeah, it does follow Benford's law distribution curve, right? So what I can say about this data, it's highly unlikely, it's unlikely that there's any fraud happening here, right? If people were to fiddle with these numbers, change this number slightly for whatever reasons to avoid tax, maybe to pay less tax, they'd be caught out right now based on what we see on the Benford distribution curve. What I'm going to show you is the effect of applying Benford's law on an image file. So I'm going to select an image file that was taken using my camera. So it's the original, right? The most original picture. So here I've got the original picture taken directly from my camera. Right, and then all I've got to do is convert this picture into a type of number called base 64. Now the type of number that we normally use is base 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There aren't any other type of digits beyond those digits, right? We only use 10 digits, base 10, whereas this one is base 64. Right, so I'm going to convert it. So click on convert. And here it is. Right, that image file that you just saw, right, is converted to base 64, and there's lots of characters here, lots and lots of characters. So that's base 64 representation of that image. What I'm going to do is right click, select all, copy. So that's in my memory now, that's in the memory. Then what I'm going to do, I'm going to paste it into this base 64, right click, paste. And then I'm going to decode that base 64 into normal decimal numbers, right? The kind of numbers that we use normally, right? So we're going to press decode. Okay, so what you've got here, it's converted it to decimal numbers, the kind of numbers that you're familiar with. And what we have here, the base 64 numbers, is a different style of numbers, different type of numbers. So obviously each and every pixel of that image was analyzed, converted to base 64. I've pasted it here, press decode, and it's converted to decimal numbers. So what I'm going to do now is select all, right click, copy, and I'm going to paste it into this different Benford's law calculator. This one's slightly better than the one I showed earlier on. Okay, right click. You can see all these numbers, loads of numbers, right? These represent the pixels in the image, the original image. Right, all I've got to do now, calculate. You can see most digits in here, most digits that represent the pixels begin with 1. Second highest is 2. It follows, kind of follows the Benford's law, okay, law distribution. Now it would have been nice if I could actually convert the image directly to base 10 number, but I couldn't find anything at the time of making this video. I've had to convert the image, as you can see, a convert image to base 64 type of number, and then use a different app to convert base 64 to a decimal type of number, and then paste that decimal number into my Benford's law calculator.